Hi, my name is Luhan Pin with matrix number KIG200155, and I will be explaining on the types of AC and DC motors as well as how do they work.
Hi guys, and my name is HENG with matrix number KIG170125. Today I will explaining the application of both AC and DC motor and how they are controlled.
Hi, my name is Jing. My matrix number is KIG170156, and today I will be explaining about the comparison between AC and DC motors.
Hi, so there are two types of motor, which are DC motor and AC motor. So for DC motor, there are three common types. The first type is the brush DC motor. Second type is the brushless DC motor, and the third type is the stepper DC motor. For the AC motor, there are two common types. The first one is the induction AC motor, and the second one is the synchronous AC motor. So in this video, we will be focusing on brushless DC motor and induction AC motor. So how does a brushless DC motor work? As their name implies, brushless DC motor do not use brushes. In brush motor, the brushes deliver currents through the commutator into coils on the rotor. So how does a brushless DC motor pass current through the rotor coils? It doesn't, because the coils are not located on the rotor. Instead, the rotor is a permanent magnet. The coils do not rotate, but are instead fixed in a place on the stator. Because the coil do not move, there is no need for brushes and commutator. In a brushless DC motor, it is the permanent magnet that rotates. Rotation is achieved by changing the direction of magnetic fields generated by the surrounding stationary coils. To control the rotation, we adjust the magnitude and direction of the current into these coils by using a computer and sensor to charge the electromagnets accordingly to rotate the rotor for full 360 degrees. So how about in the AC induction motor? In a typical three-phase AC induction motor, we create a spinning magnetic field by applying electrical current to different windings at different times. According to the diagram, imagine a current pass through the blue windings so that the pole 1 is north and pole 4 is south. Next, we pass current through the red winding so that 2 is north and 5 is south. Then through green, making 3 north and 6 south. And then again through blue, but in the opposite directions as before, so that 4 is north and 1 is south. This will produce a rotating magnetic field. In a real three-phase motor, we actually apply sine waves to all three windings simultaneously. The sine waves are all 60 degrees out of phase from each other, so that the north pole could transition smoothly from 1 to 2 and to 3 and so on. This structure is called a stator, which will produce a rotating magnetic field. The rotor, which is a conductor, would become passively magnetized due to the rotating magnetic field. But the speed of rotation of the rotor will lag behind the speed of the magnetic field rotation in the stator. Let's imagine that the AC motor started at rest. Then we supply AC current into the motor. The rotating magnetic field lines will cut through the conductors in the rotor, which induces magnetic field in the rotor according to Faraday's law. This causes the rotor to be rotated along as if it was chasing the rotating magnetic field in the stator. The speed of rotation of rotor will be close to the speed of field rotation in stator, but the speed of rotation in rotor will not be equal to the speed of rotation of magnetic field in the stator, because when both the speed of rotation of magnetic field in the rotor and stator are equal, there will be no speed difference. So no cutting of magnetic flux and no magnetic field induced, so it will not spin.
So what are the applications of AC motor and brushless DC motor? AC motor is used from heavy industrial to household environments such as fans, air conditioners, metering pumps, and speed controllers. As for brushless DC motor, It is used in computer peripherals, handheld power tools, and vehicle ranging from the model aircraft to automobiles. Now moving on to how they are controlled. Most sensorless, brushless DC motor are controlled using a microcontroller, a digital signal processor, or dedicated driver IC. However, some of them use back EMF for determining the location of the motor's rotor with respect to the motor's stator. A voltage applied across a motor's winding forces the motor's rotor to turn. The movement of the rotor through the motor's magnetic field, however, is analogous to the behaviors of a generator, and consequently, the motor not only receives and applies voltage but also generates its own voltage. This voltage is referred to as back electromotive force or back EMF, and it is proportional to the motor's rotational speed. Back EMF can be used to determine the motor's rotor speed and position, so no sensors are required. As for AC motor, it is controlled by an AC controller. An AC controller, sometimes referred to as a driver, is known as the device that controls the speed of the AC motor. An AC controller can also be referred to as variable frequency drive, adjustable speed drive, frequency converter, and etc. The AC motor receives power which is ultimately converted by the AC controller into an adjustable frequency. This adjustable output allows the motor speed to be precisely controlled.
Next, I will compare AC and DC motor. Both AC and DC motors serve the same function, converting electrical energy to mechanical energy, but their power, construct, and control differently. The most basic difference is power source. AC motor are power from alternating current, while DC motor are power from direct current, such as batteries. The efficiency of a system is defined as the amount of output received as a percentage of what was input into the system. All three technologies have power loss in form of IR losses. DC motor utilize the permanent magnet, so none of their energy needed to be used in the creation of an electromagnet. As in AC motor, the energy used by AC motor to create the electromagnet decreases the efficiency in AC motor in comparison to DC motor. At the same time, brushless DC motor are considered more energy efficient than brushed DC motor. This means that for the same input, a brushless DC motor will convert more electrical power into mechanical power than a brush motor, mostly due to absence of friction brushes. A brushless DC motor for the same mechanical output will usually be smaller than the brushed DC motor and way smaller than the AC induction motor. The brushless DC motor is smaller because its body has less heat to dissipate. From that standpoint, brushless DC motor uses less raw material to build and are better for environment. And the DC wood fuel motors are constructed with brushes and a commutator which added to the maintenance, limit the speed, and usually reduce the life or expectancy of brushed DC motor. The brush in the brush motor are usually made of carbon or graphite compound which wear during use. This brush will require maintenance and replacement over time, so the motor will need to be accessible to ensure continual maintenance. As the brushes wear, they do not create dust but noise caused by the rubbing against commutator. On the other hand, AC induction motors do not use brushes. They have long life expectancy and are cleaner and quieter because they do not have the parts rub or wear during use. Brush and brushless DC motor provide flat torque over a wide range, while AC motor often lose torque as speed increase. Oriental motor has several brushless DC packages offering speed control ranges as low as 3 RPM to as high as 4,000 RPM. For large capacity motor theory of 1000 kilowatt, the price of DC motor is much higher than the AC motor of the same capacity. If you are speaking about the brushless motor, one reason is better design, and combined with lower quantity, you have to pay for that. In addition, there are magnets which may be very expensive, and special material will allow stronger fields in smaller volume.